In this video, we're going to zoom down and look at code line by line. We're going to take a look at all the code involved in the word count algorithm in Java. So we're going to take a detailed walkthrough first of the Hadoop jar job submittal command, so you know what each part in that command is and what it does. And we'll also look at the driver code. In the second part of this series, we'll look at the map code, the reduce code, and actually do a job submittal command. So first up, when we do a job submission from the client, really from any machine with Hadoop installed, we're going to run a command like this. Hadoop jar path to the jar, the name of the class that contains the main method, for example, word count here, the input directory, and then the output directory. So first up, the Hadoop jar command tells the client to submit to the job tracker. And again, that configuration of where the job tracker lives is in the client's mapred-site XML file, which is typically in etc/hadoop/conf directory. We also pass the jar file. This jar file is what we use to actually tell Hadoop which code we're going to run. We first need to compile all of the .java files into .class files and then jar them up into an archive. Those familiar with Linux will recognize the tar command. The jar is just the Java equivalent of that. It's essentially a Java archive, a bunch of files jammed together into a single one or zipped up into a single one. The third parameter we're passing in, again, is the name of the class, which contains the main method. This tells Hadoop where our processing is to start. And then we also need to specify one or more HDFS input paths. Again, Hadoop is running on HDFS data, so we first need to load our data at this input directory that we have here. The very last thing is a single HDFS output path. This is where all of the output from the reducers in a map reduce job or the mappers in a map only job will all write their final output to this HDFS directory, a single directory. An important note, if that directory exists, word count-output, if it exists already, your job will actually fail the second time you try to run it because Hadoop knows that this data that's in HDFS could have taken anywhere from hours to days to weeks possibly to create. So if you're going to quote unquote overwrite data that's in Hadoop, you need to first delete it out. And that's an important thing to remember. So next up, let's talk about the driver, the mapper, and reducer. You'll typically make one single Java file containing one Java class for each of these things. The driver is what controls all the configuration. So this is where we set up our job level parameters. And we would specify the types of input that we're looking at, the types of output, the actual types of our key value pairs for our input and our output are typically the things we specify there. Your mapper, again, is your map logic. This is typically where most of the work is performed. So our algorithm that we're trying to run in this case, for our code, we're going to try to run the word count algorithm. This is where most of the logic lives in the mapper code itself. The reducer is the reduce logic, and again, a reducer simply aggregates the output of all the mappers into one or more final outputs for the job. So once you've created all of your .java files, your individual 3 classes, you're first going to compile it using the javac command, and this is a pretty standard command to run. The javac is compile. We're going to pass it the class path of the Hadoop class path output. Again, these ticks right here are back ticks in the keyboard. Typically the character just to the left of the 1 on most keyboards. Be careful of that, they're not single quotes. And then we pass it all of the .java files we have in a directory. So once we have compiled all of our Java, this command will generate a .class file. We'll then jar up our .class files into a single jar file with this command. Again, it's very similar to the tar command. Jar cvf mycode.jar, this is the name of the jar file that we'd create, and then passing it all of the .class files. Once you've done that, you'll now have a single jar file that contains all of the config as well as all the map and reduce code. And this job file, again, can be submitted into the job tracker. The actual code using word count, we're going to look at this in a bit, but just to refresh our memory, the word count algorithm, again, is just simply taking all the documents that we have in a single collection. So if we had a document such as this, hello Bob, it's Bob again, that contained that text, the output of the word count algorithm would produce the fact that hello appeared once, Bob appeared twice, it's appeared once, and again appeared once. So again, we're going to run this over the entire Shakespeare data set for our example to see how many times each individual word was used in Shakespeare's writing. So let's go ahead and take a look at some source code. Again, you'll need to either have set up the 4-node cluster with Cloudera Manager or the Quick Start VM. In our case, we're going to use the Quick Start VM, so let's hop over, if you could, with me to that virtual machine. So in our VMware virtual machine, let's go ahead and pop a web browser. If you've not already, you're going to want to download this Hadoop-infiniteskills-richmaro-class.tgz. We should have downloaded this, but if not, you can browse to this URL and pull the file down and unarchive it. We have already done this step in a previous exercise. So let's just pop a terminal, and we're going to go into code and data /code/word count. And if we look inside of here, we're going to see 3 .java files. We have our driver, which is just word count minus the driver at the very end. This is a pretty standard paradigm to use in Hadoop. And then we have our mapper and our reducer classes specified right there. So in this video, we're going to take a look only at word count.java, the actual driver itself. And let's go ahead and open that up with an Emacs command. And once that's pulled up, let's go ahead and expand our window and push Control X1 to make a single window. And here we see at the very top, as with most Java files, we have all of our imports at the top. The path object is what we use to specify the input and the output paths. So this is a Hadoop provided library. Our int writable is what we use for our output value class of our job. So our output itself is specified as an int or an int writable, which is serializable. We also have a text import here. Text is the output key class that we use. Again, everything in Hadoop is specified as a key value pair, so our mapper consumes a key value pair at a single time, and it outputs 0 or more key value pairs. And then our reducer consumes a key and a list of values, and then outputs possibly 0 or more key value pairs there. So everything is key value pairs in and out. And here's where we're specifying the key value pairs that we're going to consume. The job class is what controls our actual job itself, and you can see that we set that up inside of the main method, and we use this job object to set up our input and our output parameters as well as submit the job. And then our file input and output formats dictate how we consume the input from HDFS and how we write the output into HDFS at the very end of our job. So all of these imports are required, and we'll step through them each in this bit of code here. At the very top, we specify our class. This is our word count class. And again, this is the second parameter that we pass into our Hadoop jar command. So this, again, is the class that contains the main method. And the one thing we absolutely have to specify in here is a main method, which can then control all of our individual configuration for the class inside of here. We can throw an exception outside of here. We're going to set up a job object, and we specify the name of that variable, or the name of that object is job. We're going to specify a name for our job. It's very important, especially when you consider a cluster that may be running dozens of jobs in any single time. You want to specify a really particular job name, so it's easy for both yourself and other users in the system to determine which job is which. This is a somewhat acceptable name. A more acceptable name might be, for your use cases, Q3 sales report by region, or Jim's report for executive summary, something like that. You want to be as specific as possible in this job name, because this is what other folks are going to see. We set up our class names, so we specify the class for our driver with a setJarByClass method call on the job object. We're going to pass it the actual class, the word count class. So this is the class that we get after we run our javac command. And we also do the same things to set up our mapper and our reducer, again specifying the setMapper class and the setReducer class respectively. We then need to specify at the very minimum the output of our job, the output type classes for our job. This is where we see the text output key. So this output of our job will be a word or a text object. We're going to specify that class, again, which was part of our import. And we specify that the value that we output is an int writable. So this will actually be, for our job, the final number of times that each word appeared. And the key will be each word itself. So this is where we'll have hello and 1, and Bob and 2, and it's and 1, and again and 1 for each text and int writable object. We also need to specify our input and our output paths. And again, we see that we're using the file input format, which is pretty much a text input type. This is going to specify that our input is getting, for the key, it's getting the byte offset into the file. And for the value, it's using a single line of text delimited with a new line character. So again, depending on the type of input format you use, the way that we'll consume our input data is different, and the key value pairs that we send into our mapper are going to change depending on that file input format. So we need to call that with a add input path. There's other ways to add our paths, but this is a pretty standard one. We pass it our job object, and then we create a new path object. Again, this was part of base Hadoop that we passed in for our imports, and we're going to use the first argument of our job. And again, this is actually the second to the last argument. This is our input data path. And then we do pretty much the same thing with the set output path. This again specifies a text type of output. So we're going to output words as the key and our number of times that that word appeared as the value. And again, we set up that output path as the second argument or the last argument that we pass in to our final job. We're going to use our job object to specify a wait for completion. This actually specifies a blocking operation. There's a non-blocking submit method we can call as well. That will just go ahead and start picking up execution of the code on the very next line. So this wait for completion actually waits until the job is finished and then finally exits with either a 0 if everything was successful or a 1 if there was error. So we could then programmatically fire this word count.java off as a submission and then determine based on whether or not we got a 0 or 1 back the job completed. So that does it for part 1 of our walkthrough. Again, we've looked at our Hadoop jar job submittal command, and we've looked at the driver code. In part 2, we'll follow up with the map code, the reduce code, and then actually submit the job and compile our code and actually watch a job executing.